In this video, we're going to be introducing the concept of solving a quadratic equation. And we're going to focus in this video on using the method called the quadratic formula. Before you can use the quadratic formula, you got to be able to identify a quadratic. You can't just use the quadratic formula on any equation. It's only specifically used on quadratic equations. So a quadratic is an expression or an equation, it could be both, where our leading term's exponent is 2. So we can see two types here. This is an expression because it doesn't have an equal sign. An expression is just many different terms put together using addition, subtraction, multiplication, or division. As soon as we put an equal sign into that, then it becomes an equation, and we can solve it. So we can solve a quadratic equation using the quadratic formula. There's no need to solve an expression. It needs an equal sign before we can solve it. Quadratic equations come in a few different forms. The most basic and most used, I would say, is the standard form equation. So you have your first term, that x squared term. Your second term is your x to the first power, or it could be a different variable or a different letter. And then the last term is always just going to be a number without your variable. So it goes in order of powers. So the squared exponent is first, x to the first power is second, and a number without a variable comes third. And it's always set equal to 0. So there's our standard form. In standard form, the coefficients, or the numbers in front of our variables, are going to represent the values for a, b, and c. So whatever number is in front of x squared is your a term. Whatever number is in front of your x to the first value is your b term. And then that number without a variable is called the constant, and that'll be your c term. Sometimes quadratic equations may have a missing b or c term. We can't miss the a term because then it's no longer a quadratic, but it could be missing the b term or it could be missing the c term. And we can see a couple examples here. In this example, we're missing that middle term, that b term. And then in this example, we're missing that last term, that c term. As we're going to find out when we use the quadratic equation, when we substitute a value that is missing, we're going to substitute 0. So there are two main methods to solve a quadratic equation. The quadratic formula is your most basic way. It can help you solve any quadratic as long as it has a solution. It can also tell you if it doesn't have a solution. After that, we have a lot of different factoring methods, which allow us to hopefully take a shortcut rather than use the quadratic formula. But those take a few days to practice, maybe even longer to get the hang of them so that they can be more efficient. If you ever struggle with a factoring method or forget a factoring method, always fall back on your quadratic formula. This is like your skeleton key or your eject button, your parachute. It's going to help you solve a quadratic no matter what. There are lots of different ways to memorize the quadratic formula. Some people sing songs and tunes of nursery rhymes like Pop Goes the Weasel. But there are many, many ways that people have come up with to memorize this. Take a look online and see if you can find a method that works best for you so you can memorize this formula. All right, a couple steps to help you use your formula. Always organize your quadratic into standard form first. That allows you to identify your a, b, and c values, which allow you to substitute into your formula and solve. And when we simplify the quadratic formula, we always use order of operations, although it may look a little funny. So I'll explain how PEMDAS can help us do that. Let's do this first example on the left. Let's solve this quadratic equation. Let's check and make sure it's in standard form. Our first term is x squared, our second term is x to the first power, and our third term doesn't have a variable, and it's set equal to 0. So it seems like it's in standard form. We can go ahead and identify the a term. It might be invisible if it's 1, but it's in front of x squared there, so a is 1. The number in front of x to the first power is positive 3, so b is 3. And c is negative 10. Numbers are going to keep the sign that's in front of them, so your c value is negative 10. So we just substitute those into our equation. One common mistake is that first value. The opposite of b is what we put first. So if b is positive, we're going to put a negative value. If b is negative, we're going to put a positive value. So in this case, b is positive 3, so I'm going to write negative 3. Plus or minus. We're going to have two different solutions maybe. The square root symbol, and underneath that is going to be a lot of stuff, so make sure you draw your radical really long. We're going to put b squared, or in this case 3 squared, minus 4 times a, which is 1, times c, which is negative 10, and the entire thing is being divided by 2 times a, or in this case 2 times 1. So to simplify using order of operations, under a radical is treated like parentheses, so we're going to simplify that first. 3 squared is 9. I'm going to keep my sign attached to that 4, so this is negative 4 times 1 times negative 10, which is positive 40, so we're going to write plus 40. Keep simplifying under the radical, so 9 and 40 give you 49. Now we're on to the e part of PEMDAS, because radicals are treated like exponents. So the square root of 49 is 7. So now we got two problems. We got negative 3 plus 7 divided by 2 and negative 3 minus 7 divided by 2. So simplifying and solving for each, negative 3 plus 7 is 4, and 4 divided by 2 is 2. Over here, negative 3 minus 7 is negative 10, and negative 10 divided by 2 is negative 5. So we got two solutions, positive 2 and negative 5. And it doesn't matter what order you write your solutions in, as long as you give them all. Let's do another example. This time, we're not in standard form first. The right side is not set equal to 0. So we got to move that negative 4 over to the other side of the equal sign, which means we're going to do the opposite. So we're going to add 4. It becomes positive 4 over here. That's our c term. It doesn't have a variable, so we're going to put it last. 4x squared is our first term, and negative 8x is our middle term or second term. Now we're in standard form. We can identify our a, b, and c values. A is 4, the number in front of x squared. B is negative 8, the value in front of x to the first power. And c, our constant, is positive 4. Substituting them into the quadratic formula. This time our b is negative 8, so the first thing we write is the opposite of b. We're going to write positive 8. Plus or minus the square root of b squared, or negative 8 squared. Make sure you put parentheses around a negative value in this formula when you square it. You're going to square a number that includes the negative. So this is negative 8 times negative 8. And then we have negative 4 times 4 times 4, or the opposite of 4 cubed is another way to say it. That also gives us 64, but it's negative 64, so we're going to write minus 64 there. So if we have 64 minus 64, that's 0, and the square root of 0 is 0. So anytime your radical value becomes 0, you always know you have one solution, because that whole thing is going to go away, and you're just left with your first number divided by the denominator. So 8 divided by 8 is 1. You could add 0 and subtract 0, but it's not going to change anything. We just have one solution, positive 1. You can always check your solutions, plugging them back in to the original equation, and they should both work and make the right side equal 0. All right, let's do an example where we're missing a term. I'm going to skip this left example, although you can go ahead and look at it. I'm going to focus on the right example. So in this case, we're missing our b term. We're going to substitute 0 for b. Anytime you have a quadratic that is missing a b term, hopefully you don't use the quadratic formula. We can use our algebra steps and a square root to solve. If we add 8 to both sides and square root both sides, we can jump to our solution much easier and much faster than using the quadratic formula. But we can also use the quadratic formula if you forget that method. So if a is 1, b is 0, and c is negative 8, then we can substitute all of that into our quadratic formula and simplify. Under the radical, we have 32 now. And so this is going to give us an irrational solution. We got to simplify the square root of 32 and keep it in radical form. So we're going to break up 32 into 16 times 2. That allows us to take out the square root of 16. Just because we had 0 in front does not negate that positive and negative symbol. Keep that in the front of a square root. and then keep simplifying. And 4 divided by 2 is 2. So we get two solutions, and they're both irrational.